There is a particle that for decades existed only as a hypothesis, and when it was finally found, it confirmed an essential part of our understanding of the universe. The Higgs boson not only explains why particles have mass, but also opens up a range of questions that could redefine the fate of the cosmos. What secrets does this particle hold? Why does its very existence seem so finely tuned, almost as if the universe were calibrated to allow us to be here? In this journey, we will explore the most surprising curiosities of the Higgs, from its possible connection to dark matter to its role in the stability or instability of the universe itself. The Higgs boson is known as the God particle, a nickname that may sound grandiose but reflects the importance of its role in the creation of mass. But why is this relevant? Mass is fundamental to the existence of matter as we know it. Without the Higgs boson, the particles that make up everything around us, from the stars in the sky to the air we breathe, would not have the necessary mass to form atoms, and consequently, we would not exist. But do we really understand everything that this discovery entails? Despite its relevance, the Higgs boson remains an enigma. There are open questions that lead us to consider what mysteries lie behind this phenomenon. Why, despite its discovery in 2012, do we still face so many unknowns? Science progresses, but each answer seems to open the door to new questions. For example, if the Higgs boson is responsible for mass, why can't it explain all the weight of the universe, and what about the vacuum surrounding it? It could be that this Higgs field, which gives mass to particles, is also responsible for an instability that could threaten the very existence of the cosmos in the distant future. Moreover, where are the supersymmetric particles that were expected to be found alongside the Higgs boson? Scientists had high hopes that their discovery would reveal new aspects of the universe. However, so far those particles remain elusive. And speaking of elusive, we cannot forget dark matter, that mysterious component that seems to make up most of the universe but remains invisible and difficult to detect. Could the Higgs boson have an unexpected role in this story? It is fascinating to think that despite the advances in our understanding, the Higgs boson also raises questions about the very nature of the universe. Why does it have such precise mass? Is it possible that the universe is finely tuned to allow for the existence of life as we know it? These questions lead us to reflect on our own existence and the place we occupy in the vast cosmos. In summary, the Higgs boson is not just another particle, it is a key that could unlock the secrets of the universe. As we delve into the mysteries surrounding this phenomenon, we realize that each answer is just the beginning of new questions. And the quest to understand the cosmos continues. What other secrets will the Higgs boson reveal to us in the future? The adventure has just begun. Have you ever imagined what would happen if the universe, as we know it, were on the brink of collapse? This is the intriguing enigma of vacuum stability, one of the most fascinating questions surrounding the Higgs boson. This small but powerful component of the universe not only plays a crucial role in the creation of mass, but may also have terrifying implications for the future of everything we know. To understand the problem of vacuum stability, it is essential to remember that the Higgs field permeates all of space. But what does this really mean? In simple terms, the Higgs field acts as a kind of support that allows particles to have mass. Without this field, matter as we know it could not exist. However, the question remains, what happens if this field becomes unstable? Imagine a serene lake where the water is calm and in balance. This lake represents the vacuum, a state where everything seems to be in order, but suddenly a wave can disturb that tranquility, creating chaos. In the context of the universe, that wave would be a change in the Higgs field. Scientists have proposed that under certain conditions, the Higgs field could enter a state of lower energy, meaning that the vacuum would become unstable and could lead to a cataclysmic collapse. But how can this happen? The theory suggests that if the Higgs field is in a state of instability, it could unleash a chain reaction that would alter the fundamental properties of matter. This could result in a universe where the laws of physics no longer apply and matter as we know it could disintegrate. Imagine a universe where everything that exists turns to dust. That is the magnitude of this mystery. And here is where it gets even more curious. Some scientists believe that this collapse could be an event that occurs in an extremely distant future, perhaps billions of years from now. But isn't it unsettling to think that the structures that constitute our reality are ultimately fragile? The idea that at some point in the future the universe could cease to be what it is raises profound questions about the nature of the cosmos and our place in it. Moreover, the fact that there is uncertainty about whether we are living in a stable vacuum or an unstable vacuum adds another layer of mystery. How can we be sure that our existence is not just a mirage in a sea of possibilities? Science, in its constant quest for truth, faces a dilemma. Should we worry about vacuum stability or simply continue with our lives ignoring what we cannot see as physicists continue to investigate? Theories and models emerge that attempt to explain vacuum stability and its relationship with the Higgs boson. However, despite these efforts, the enigma persists. Is it possible that deep down the universe is playing a kind of cosmic game that we do not yet fully understand? Science has its limits, and sometimes it finds itself trapped in a maze of unanswered questions. And this is where the role of research comes in. The search for answers about vacuum stability and the Higgs boson has led scientists to experiment with particle accelerators, such as the Large Hadron Collider. These experiments seek to unravel the secrets of the universe, but often leave more questions than answers. Are we really closer to understanding the nature of the vacuum? Or are we simply digging deeper into the mystery? In the midst of this dilemma, it is important to remember that knowledge advances by leaps and bounds. Throughout history, scientists have challenged entrenched beliefs and expanded our understanding of the cosmos. However, the enigma of vacuum stability remains a reminder that science is a constantly evolving journey. What new discoveries await us on the horizon? The relationship between the Higgs boson and vacuum stability also raises philosophical questions. What does it mean for us as human beings to know that the reality we perceive may be unstable? Should we be concerned about the future of our universe, or should we focus on the present and how we live our lives? These questions are the essence of human curiosity, and each discovery in modern physics brings us one step closer to the answers. In conclusion, the enigma of vacuum stability is a reminder that the universe is a place full of mysteries and surprises. As we continue to explore and challenge our preconceived notions, the Higgs boson offers us a window into the unknown. Perhaps we will never fully resolve all the mysteries it presents, but the journey itself is what truly matters. And you, what do you think? Would you dare to explore more about the secrets the universe holds? If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. What if I told you that the Higgs boson, that particle that helps explain why we have mass, also has a dark secret? Despite its discovery in 2012, many scientists find themselves in a state of awe and frustration. Why, despite expectations that the Higgs boson would reveal a world full of new particles, have we seen nothing? This is the enigma of the missing supersymmetric particles. Supersymmetry is a fascinating theory that suggests that every known particle has a partner, a kind of twin that could explain many of the mysteries of the universe. Imagine that every electron has a supersymmetric electron that we have not been able to detect. Wouldn't it be incredible to find these companions and better understand the fabric of reality? However, despite years of searching in particle colliders like the Large Hadron Collider, these siblings remain hidden. Why do they not appear? Some scientists thought that the discovery of the Higgs boson would be the key that would open the door to a new realm of particles. In theory, the boson should have left clues about its supersymmetric companions, but surprisingly, the search has been fruitless. What does this mean? Are we looking in the wrong place, or perhaps supersymmetry is a concept that does not fit reality? Some researchers wonder if the energies used in experiments are simply insufficient to reveal these particles. It is believed that the supersymmetric partners could be much heavier than the Higgs boson, making them difficult to detect. Could it be that in trying to understand the universe, we are missing something that is just beyond our reach? The absence of these particles not only raises questions about supersymmetry, but also calls into question the validity of the Standard Model. This theory has been the cornerstone of particle physics for decades, but the lack of evidence for supersymmetry leads some to wonder if we are facing a crisis of confidence. Is it possible that what we think we know about fundamental particles is outdated? Moreover, the search for the missing supersymmetric particles leads us to question the very nature of the Higgs boson. If this is the only one of its kind, what does that mean for our understanding of the universe? Some physicists suggest that the existence of a single boson could be a hint that there are more mysteries to uncover. Meanwhile, the scientific community continues to investigate, exploring new theories and experiments. Is it possible that one day we will discover those elusive companions? Hope is a powerful engine in science, and each new experiment brings with it the possibility of revealing the unknown. But what will happen if we never find evidence of supersymmetry? Will we remain trapped in a maze of unanswered theories? There is no doubt that the search for supersymmetric particles is a journey filled with uncertainty. At the same time, it teaches us that knowledge is a constantly evolving process. Each finding, each failure brings us one step closer to understanding the puzzle of the universe. Who knows what secrets still await us in the vast and mysterious cosmos? It is fascinating to think that, despite all the advancements, there is still so much we do not know. The absence of these particles reminds us of the humility needed in science. No matter how advanced we think we are, there will always be more questions than answers. Could it be that the key to solving this enigma lies in yet unexplored places? With each failed attempt, human curiosity feeds on new ideas and approaches. Perhaps the answer to the absence of supersymmetric particles lies in a dark corner of physics that we have yet to touch. Or maybe it lies in the understanding that the universe is stranger and more complex than we ever imagined. Meanwhile, the Higgs boson remains a beacon in the darkness, guiding us through the mysteries of the cosmos. Each discovery in this field is an invitation to keep exploring, to not give in to uncertainty. Science advances, and with it, our understanding of the universe expands. So the next time you think about the Higgs boson, remember that its story is far from complete. The search for the missing supersymmetric particles is just one part of a much larger puzzle. Science teaches us that, although some mysteries may seem unreachable, there is always room for surprise and wonder in the vast universe that surrounds us. The Higgs boson, known as the God particle, has revolutionized our understanding of modern physics. However, despite its crucial role in the creation of mass, a fascinating enigma remains. Why doesn't it answer all our questions about mass? What other secrets does it hide? The theory of the Higgs boson tells us that it provides mass to subatomic particles through its field. But is that all? Is there something more that we are not seeing? Although we have managed to explain how certain components of the universe acquire their mass thanks to this boson, there is still a significant gap in our understanding. Particles like electrons and quarks, which make up the matter around us, depend on this phenomenon, but not everything is resolved with its existence. It is intriguing to think that, while the Higgs boson is fundamental, it does not explain the mass of all particles. For example, what about gravity? The mass of an object influences how it behaves in a gravitational field, but the Higgs boson does not fully address the role that gravity plays in the creation of mass. Why is there such a notable difference between the masses of fundamental particles and that of the Higgs itself? This type of question leads us to reflect on the true meaning of mass in the universe. Physicists have begun to question whether there are other forces or particles that could be involved in this mystery. Some theories suggest that there could be unknown interactions that we have not managed to observe. Could the Higgs boson be just a part of a much larger puzzle, one that includes yet undiscovered forces? What if the answer to this mystery lies beyond our current models? Moreover, there is the possibility that the Higgs boson interacts with other fundamental forces in ways that we have yet to understand. This raises the question of whether mass is simply an emergent property of a more complex interaction. Is it possible that there is a connection between the Higgs and phenomena that we have not fully explored? The search for an answer leads us to consider the role of energy in the creation of mass. The Higgs boson has a direct relationship with energy in the universe, but what is the origin of this energy? Could there be energy sources that we have not discovered that influence the mass of particles? What seems clear is that mass and energy are interrelated, but how they are connected remains a mystery. Some scientists suggest that the Higgs boson could be just a component of a larger system that gives rise to mass. This leads us to wonder if there are other dimensions or realities that could influence what we understand as mass. Could there be other types of Higgs that escape our current understanding and could offer more answers about mass? Theories about supersymmetry also open new doors in this dilemma. According to these theories, each particle in the Standard Model would have a supersymmetric partner. However, so far we have not seen evidence of these particles. This forces us to ask, is it possible that the Higgs boson is somehow linked to these missing particles? What if their existence is the missing key to understanding how mass is created? The dilemma of the mass of the Higgs boson itself is also fascinating. Its observed mass is different from what we theoretically predict. Why does this discrepancy exist? Is it indicative of something being wrong in our current understanding of the Standard Model of physics? Each new finding generates more questions than answers, and this is what fuels scientists' curiosity. Experiments in particle accelerators continue to yield data that do not always align with our expectations. This leads us to question whether we are correctly interpreting the nature of the Higgs boson and its role in the universe. Perhaps there are aspects of reality that we have not considered and that could radically change our understanding of mass. Every step forward in this research opens the door to new questions. Could we discover that mass is not an intrinsic property of particles, but something that results from deeper interactions? Is it possible that by uncovering the mechanism behind mass, we could also gain a better understanding of the nature of the universe itself as we continue to explore these mysteries? It becomes clear that the Higgs boson is just the tip of the iceberg. The search for answers takes us on a journey through physics that could redefine not only our theories but also our perception of the universe. Each discovery is an invitation to delve deeper into the unknown, and with every question we get a little closer to unraveling the secrets that the Higgs boson and mass guard so jealously. The Higgs field is one of the most fascinating components of the universe, but despite its importance, there are still many unanswered questions. One of the most intriguing is the Higgs field stable throughout the universe? To understand the gravity of this question, we must first think about what a vacuum collapse would mean. Can you imagine a universe where everything crumbles, where the laws of physics as we know them suddenly cease to exist? That possibility, although it seems straight out of a science fiction movie, is a serious topic of debate among physicists. The stability of the vacuum is not just an abstract concept, it refers to how the Higgs field behaves under different conditions. In an ideal scenario, the Higgs field is constant and balanced, allowing particles to acquire mass in the way we know. However, some scientists suggest that this balance may be fragile. What would happen if, in the distant future, the Higgs field became unstable? It could trigger a catastrophic event that would completely transform our reality. But is this really possible, or is it just speculation? The key to understanding this dilemma lies in vacuum energy. When we talk about vacuum energy, we refer to the lowest state that the Higgs field can reach. Theoretically, this state should be the most stable, but there are indications that there could be other states representing a lower equilibrium. If the Higgs field were in an unstable state, it would mean that the universe could change radically in an instant. Are we really living in the best of all possible worlds? Moreover, the behavior of the Higgs field can vary in different regions of the universe. What does this mean for our understanding of physics? Imagine a universe where the Higgs field acts differently in different places. This could lead to a variety of phenomena that we have not yet been able to observe. How would particles behave in a universe where the Higgs is not the same everywhere? The implications are profound and challenging. The study of the Higgs field also leads us to reflect on the fate of the universe. Some scientists speculate that if the Higgs field becomes unstable, it could be the precursor to a major change in the structure of the cosmos. But what kind of change? The theory suggests it could lead to an accelerated expansion of the universe or even a sudden collapse. Could it be that despite our apparent stability, the universe is on a path toward an uncertain destiny? To complicate matters further, physicists are exploring the idea that the Higgs field might be related to other universal phenomena, such as dark energy. How are these concepts linked? Dark energy, which is believed to drive the accelerated expansion of the universe, could have some connection to the stability of the Higgs field. If so, the very nature of our cosmos could depend on a delicate balance between these forces. At the heart of this issue is the hierarchy dilemma. Why is the mass of the Higgs boson so different from that of other particles? This discrepancy suggests that there is something more at play, something we have yet to fully understand. Could this mystery be related to vacuum stability? The lack of clear answers leaves us with more questions than certainties. As we advance in our understanding of the Higgs field, we face the reality that there is still much we do not know. How does this field really behave in extreme situations? Current experiments are providing valuable data, but they have not yet solved all the puzzles. Could it be that the Higgs field holds hidden secrets that lead us to a new understanding of physics? Research in this field is an active area of study and continues to generate debate. Theories evolve, and with each new finding, new questions arise. Are we close to unraveling the mysteries of the Higgs field, or have we merely scratched the surface? Each discovery could bring with it more enigmas, challenging our understanding of what we think we know. The idea of a changing universe where vacuum stability may not be as solid as we think is a concept that invites us to reflect on the very nature of our existence. Are we living in a privileged moment, or are we in a precarious balance? With each advance in physics, new questions arise about the future of the cosmos. Finally, the mystery of vacuum stability reminds us that, although we have made great strides in our understanding of the universe, there are many secrets yet to be uncovered. Physics, in its quest to unravel these enigmas, takes us on a fascinating and often bewildering journey. What does the future hold for us? The answer to that question could change our view of the universe forever. The quest to understand the Higgs field and its relationship with vacuum stability is just one chapter in the endless book of science, filled with intrigue and wonders yet to be discovered. Could it be that the universe has more than one Higgs boson? Although it seems incredible, some scientists believe the answer is affirmative. The idea that there could be multiple versions of this fundamental particle opens up a fascinating array of possibilities. But why is it so important to explore this notion of Higgs multiplicity? First, let's think about what we know. The Higgs boson, discovered in 2012, has been a major triumph for physics, but physicists do not stop there. In their quest to understand the universe, some theorists have begun to speculate that, instead of being a single particle, the Higgs could be part of a family of bosons. How could this change our understanding of nature? Imagine that there are different types of Higgs bosons, each with unique properties. Some could have different masses, interact in various ways with other particles, or even play different roles in the creation of mass itself. What implications would this have for modern physics? We could be facing a landscape of hidden particles that we have yet to observe. One of the intriguing questions arising from this theory is, why haven't we found these other versions of the Higgs? The answer may lie in the energy at which they are produced. The collisions we have conducted in accelerators like the Large Hadron Collider are extremely powerful, but perhaps they are not powerful enough to reveal the existence of these additional bosons. Are we looking in the wrong place? Some theorists suggest that these hidden bosons could be related to phenomena we do not fully understand yet, such as dark matter. This mysterious form of matter that makes up a large part of the universe could have interactions with a different Higgs. Could it be that the key to understanding dark matter lies in a boson we have not yet detected? In the realm of particle physics, the idea of Higgs multiplicity also raises questions about the unification of fundamental forces. If there are several bosons, it could be that each has a specific role in the interaction between forces, uniting aspects of gravity, electromagnetism, and nuclear forces. Could this be a step towards a more complete theory? Moreover, the existence of multiple Higgs bosons could help resolve the energy dilemma mentioned earlier. If the universe has different Higgs fields, perhaps some of them could be responsible for the variation in particle mass in different locations. This could explain why the energy of the Higgs field is not constant throughout the cosmos. Are we on the brink of a solution that could radically change our view of the universe? However, the idea of multiple Higgs bosons also faces challenges. Particle physics is a field where experimental evidence is fundamental. While we can theorize about the existence of these bosons, we need to find a way to detect them. Are we ready to move in this direction? Current technology allows us to make incredible discoveries, but there are also limits we must overcome. In the meantime, the concept of multiple Higgs bosons drives scientists to think more creatively. Physics is not just a strict field of study, but a space where imagination meets logic. Could it be that the answers we seek lie beyond what we have considered so far? The multiplicity of the Higgs invites us to explore new frontiers. As we delve deeper into these ideas, it is essential to remember that science is a continuous process. What seems like a mystery today could become an accepted truth tomorrow. The possibility that there is more than one Higgs boson is a reminder of how little we truly know about the universe. Are we ready to accept that there are more questions than answers? Every discovery we make about the Higgs boson brings us closer to understanding not only its role, but also that of the universe as a whole. The search for these additional bosons could lead to a new era in physics, where knowledge expands in ways we never imagined. What will be the next great breakthrough in our quest for truth? For now, the mystery of Higgs multiplicity remains a topic of debate and exploration. This path is filled with uncertainties and also potential. So, as we continue our search, let us remember that every question we pose is an open door to new understanding. What discoveries does the future hold for us? Only time will tell. What do we really know about the mass of the Higgs boson? At first glance, it may sound like a simple question, but the answer is much more complex than we might imagine. The Higgs boson has been the protagonist of a discovery that changed modern physics. Yet its own mass remains a mystery that leaves us with more questions than answers. Why does its observed value seem to not entirely match theoretical predictions? To understand this enigma, we must first remember that the Higgs boson is essential in the universe, as it is related to how particles acquire mass. However, scientists have been grappling with the discrepancy between what was expected to be found and what has been measured. Why does this difference exist? Theories prior to the discovery of the Higgs boson predicted that its mass should be much lighter, perhaps around a few hundred giga-electron-volts. But when it was finally detected in 2012 by the Large Hadron Collider, its mass was measured at approximately 120 giga-electron-volts. This value is not only higher than expected, but it also raises a series of unsettling questions. What does this mean for our understanding of the universe? One possibility that has emerged is that the standard model of physics, which has been the backbone of our understanding so far, might be incomplete. This leads us to a troubling reflection. If the Higgs boson is more massive than theoretical models suggest, could it indicate the existence of new particles or forces that we have yet to discover? Moreover, the mass of the Higgs has profound implications. If its value is so precise, could it be that the universe is fine-tuned to allow for our existence? This concept, known as fine-tuning, suggests that if the mass of the Higgs boson were different, the conditions for life as we know it could not exist. Is it possible that the universe is designed in such a way that life has a chance? Theories of physics beyond the standard model, such as supersymmetry, attempt to address these mysteries, but so far they have not been able to provide definitive answers. Could it be that the Higgs boson is just the tip of the iceberg of a much larger phenomenon? This is a question that troubles researchers. Additionally, there is the dilemma of how the mass of the Higgs relates to other fundamental forces. For example, theories suggest that the relationship between the mass of the Higgs and gravity could be crucial for understanding how the universe works. However, so far we have not been able to establish a clear link. Why is it so difficult to connect these pieces of the puzzle? Another intriguing dimension is the role that the Higgs boson could play in cosmic phenomena. Its mass could influence events such as the expansion of the universe or the formation of large-scale structures. Is it possible that the fate of the cosmos is tied to the nature of this boson? Scientists also face the hierarchy problem, which refers to the large difference between the mass of the Higgs and the masses of other fundamental particles. This mismatch raises questions about the nature of the forces that govern the universe. Why is there such a disparity? Ultimately, the mass of the Higgs boson is not just a number on a chart, it is an indicator of the health of our theory of the universe. The more we understand about it, the more we realize that each discovery opens the door to new questions. How far will our curiosity and desire to understand take us? The fact that the mass of the boson does not match predictions is a reminder that scientific knowledge is a continuous journey. Each answer leads us to new unknowns, and the Higgs boson is a perfect example of this. What other secrets does the universe hold for us? On the horizon of research, some scientists suggest that we might be on the brink of a paradigm shift. If we manage to understand the mystery of the Higgs mass, we could be one step closer to unraveling other mysteries of the cosmos. Are we about to discover that the universe is even stranger and more fascinating than we had thought? As we explore these mysteries, it becomes clear that the Higgs boson is not only a fundamental piece in the puzzle of physics, but also a symbol of what remains to be discovered. Thus, the quest for answers about its mass reminds us that knowledge is an endless journey, full of surprises and wonders. In short, the mystery of the mass of the Higgs boson is not just a scientific enigma, but also an invitation to continue exploring and questioning what we think we know. Are we ready to move forward on this adventure? The answer could change our understanding of the universe forever. What is dark matter, and why is it considered one of the great mysteries of the universe? Although we cannot see or touch it, it is estimated to represent approximately 27% of the total content of the cosmos. However, its nature remains elusive, and while scientists have proposed various theories to explain it, we still do not have definitive answers. This is where the Higgs boson comes into play. One fascinating aspect of the Higgs boson is that it could have some kind of relationship with dark matter. But how could a boson, which is responsible for giving mass to particles, be connected to something we cannot see? Some scientists suggest that the Higgs field might interact with dark matter particles, giving them a form of existence that we do not yet fully understand. Imagine a world where the Higgs boson acts as an intermediary between the visible and the invisible, a bridge connecting the matter we know with that which we cannot perceive. Theoretical models suggest that these interactions could be extremely subtle, making them difficult to detect. So how do we know that these interactions might exist? The answer lies in the discrepancies we have observed in the behavior of galaxies. The way they spin and move cannot be fully explained by visible matter. Something else is influencing their dynamics, and many believe that something is dark matter. Now, if the Higgs boson has something to do with dark matter, why haven't we detected it yet? It is possible that dark matter particles are so different from those we know that they simply do not fit into our current model of physics. Remember that the Higgs boson was discovered just a few years ago, and particle physics feels like a vast ocean of mystery. Every discovery we make leaves more questions than answers. What if the Higgs boson is just the tip of the iceberg? Some theories suggest that there could be other types of particles, which we have not yet been able to observe, that interact with the Higgs field in ways that could reveal more about dark matter. It is a fascinating puzzle, and each new piece we find brings us a little closer to the truth. Moreover, the fact that the Higgs boson has such specific and precise properties raises an intriguing question. Could it be that its very existence is related to dark matter? This could imply that the universe was designed in such a way that dark matter and the Higgs boson coexist, each playing a crucial role in the grand scheme of things. But what implications would this have for our understanding of reality? Some researchers are exploring the idea that the Higgs boson could be a mediator of new forces or interactions that we have not yet discovered. If so, could the Higgs boson open the door to new dimensions where dark matter behaves in completely different ways? This idea, although it sounds like science fiction, is being seriously studied in the world of theoretical physics. The connection between the Higgs boson and dark matter is also related to the broader question about the nature of the universe. Is it a place where everything that exists can be observed and measured? Or are there aspects of reality that remain hidden, waiting to be discovered? If the Higgs boson plays a role in dark matter, it could mean that there is still much to explore in our understanding of the cosmos. It is essential to remember that science is a constantly evolving process. Every time we think we have solved a mystery, new questions arise. The search for dark matter and its relationship with the Higgs boson is a perfect example of how science advances through curiosity and questioning. Each new theory proposed pushes us to think beyond the known, and so the connection between the Higgs boson and dark matter is not only a mystery, but also an invitation to continue exploring. It reminds us that the universe is full of secrets waiting to be unveiled. Every discovery in this field could change our understanding of physics and ultimately our place in the cosmos. In summary, the relationship between the Higgs boson and dark matter is a fascinating area of research filled with enigmas. As we continue to investigate, each small advance could lead us to answers that today seem distant. Science invites us not to give up, to keep asking questions, and to always seek beyond what we already know. So the next time you think about the Higgs boson, remember that it is much more than just a simple particle. It could be the key to unraveling one of the greatest mysteries of the universe, a mystery that leads us to question the very nature of reality. The search for answers continues, and we are here, ready to explore the unknown. Why does the universe seem perfectly calibrated to allow for the existence of life as we know it? This is a mystery that has intrigued scientists for decades, and the Higgs boson plays a crucial role in this question. The mass of the Higgs boson is not just a simple number, it is an extraordinarily precise value that seems designed to maintain the delicate balance necessary for the formation of the cosmos. But how can a particle have such a monumental impact on the structure of the universe? The answer lies in its interaction with other particles and its influence on the creation of mass. If the Higgs boson had a slightly different mass, the fundamental forces of the universe could behave very differently. Can you imagine a universe where electrons could not form atoms? That is the reality we might face if the Higgs boson had a different mass. The idea of fine-tuning leads us to a deep reflection. Is this universe the only possible one? Or are there infinite variations where the conditions are too extreme to allow for life? Physicists have proposed that if the universe had a different set of laws and constants, we would be in a very different place. But the fact that we are here pondering these mysteries suggests that there is something special about our cosmos. One fascinating aspect of fine-tuning is that it is not just about the mass of the Higgs boson, but about a series of physical constants that seem to be perfectly adjusted. For example, if the electromagnetic force were a little stronger or weaker, nuclear fusion in stars might not occur, and without stars, there would be no light, heat, or, of course, life. How is it possible that all these variables align so precisely? Some scientists suggest that this calibration could be a sign that our universe is just one of many in a multiverse. In this scenario, there are infinite universes with different parameters, and we simply inhabit one that favors life. But how can we test this theory? At this moment, we are limited in our ability to explore beyond our own observable universe, which adds a layer of mystery to the discussion. The notion of fine-tuning also raises philosophical questions. Is it an astonishing coincidence, or is there a purpose behind this precision? Some argue that the existence of a creator or a higher power could be an answer to this question. However, science strives to find answers within physics itself without resorting to supernatural explanations. An intriguing aspect is the role of gravity in fine-tuning. The way the Higgs boson interacts with gravity is still an enigma. While the Higgs is responsible for giving mass to particles, gravity acts as a force that affects the structure of the universe on a large scale. What if the Higgs boson also had a role in gravity? This is something that physicists are still trying to unravel. The fine-tuning of the Higgs boson also leads us to question the future of the universe. If the Higgs field plays a role in the expansion of the cosmos, could its behavior determine how the universe will end? Some theories suggest that if the Higgs field behaves differently in the future, it could even trigger a vacuum collapse, leading to a catastrophic end. It is astonishing to think that such a tiny particle can have such vast implications. The Higgs boson not only helps us understand the universe we live in, but also raises more questions than it answers. The quest for answers to these mysteries is a journey that continues, and each discovery seems to open new doors to even deeper enigmas. As scientists delve deeper into the Higgs boson and its role in fine-tuning, they are getting closer to a more complete understanding of the nature of the universe. But will they manage to solve all the puzzles it presents? The history of physics is a story of endless questions, where each answer generates new uncertainties. Exploring these topics is not only fascinating, but also highlights the complexity and beauty of the universe. It invites us to reflect on our place in it and on the laws that govern it. There is a sense of wonder in considering that despite all the scientific advancements, there is still so much we do not know. Ultimately, the mystery of the fine-tuning of the Higgs boson reminds us that science is a journey, not a destination. Each discovery brings us closer to the truth, but also confronts us with the reality that the universe is a place full of surprises and wonders. It invites us to keep asking questions, to keep exploring, and to never cease to marvel at the extraordinary complexity of the cosmos. So the next time you look up at the sky, remember that there is a world of mysteries waiting to be discovered. From the fine-tuning of the Higgs boson to the secrets that remain hidden, the universe is a vast puzzle that we may never stop trying to solve. And that, in itself, is an invitation to keep exploring, questioning, and, above all, marveling at the majesty of the cosmos. Since the dawn of cosmology, scientists have sought answers about the events that shaped our universe. Among these phenomena, cosmic inflation stands out as one of the most intriguing. What exactly is cosmic inflation, and how is it related to the Higgs boson? To understand this, it is essential to travel back in time, right after the Big Bang, when the universe experienced an extremely rapid expansion. In fractions of a second, the cosmos stretched, creating the necessary conditions for the formation of galaxies and structures we know today. Imagine a balloon inflating quickly. In this process, initial irregularities are amplified, and what seemed to be a homogeneous space becomes a place filled with variations. But what drove this rapid expansion? This is where the Higgs boson comes into play. It has been proposed that this small but powerful particle could have played a crucial role in the mechanism that triggered inflation. The idea is that by interacting with the Higgs field, energy was generated that caused this uncontrolled expansion. However, this raises a fascinating question. Why did inflation stop? Once the universe reached a significant size, something caused this accelerated expansion to cease, allowing the universe to cool and begin forming the particles and forces we know today. Some scientists suggest that the Higgs boson might have been responsible for this break. But how? This small yet significant component of the universe may have provided the necessary stability for the cosmos to transition from a phase of unrestrained expansion to a more ordered one. As we explore further, questions arise about the nature of this interaction. If the Higgs boson was indeed responsible for inflation, does that mean there is a direct link between the creation of mass, which the boson facilitates, and the events that shaped our universe? It's as if the Higgs boson not only gives weight to particles, but also influences major cosmic events. But how can we verify this hypothesis? The truth is, so far, it remains a mystery. The theory of cosmic inflation also provides a framework for understanding why the universe is so homogeneous and isotropic on large scales. The Higgs boson could be the key to unraveling this mystery. But experimental evidence is hard to come by. As scientists work on particle accelerators like the Large Hadron Collider, the search for evidence becomes a race for knowledge. Will we find proof that the Higgs boson was present during those primordial moments? Only time will tell. As we advance in our understanding of these interactions, another intriguing question arises. If the Higgs boson was an integral part of inflation, could there be other phases of the universe that we have yet to discover? Theories suggest that the cosmos could undergo cycles of expansion and contraction, and the Higgs boson could be the main actor in this cosmic drama. If this is true, the future of the universe might be much more intertwined with the Higgs than we think. The connection between the Higgs boson and cosmic inflation also leads us to raise questions about the fate of the universe. If inflation was driven by the Higgs field, does this indicate that the universe could experience another phase of accelerated expansion in the future? Some theories suggest that if the Higgs field behaves differently in various regions of space, we could witness cosmic phenomena that challenge our current understanding. Moreover, the study of inflation and the Higgs boson could open new doors to discoveries about hidden dimensions. Some theories suggest that there could be more dimensions beyond the four we know, and the Higgs boson might be a key to accessing those realities. Is it possible that by better understanding the role of the Higgs in inflation, we could glimpse a universe much broader and more complex than we ever imagined? As scientists continue to investigate, each new discovery about the Higgs boson may shed light on the mysteries of cosmic inflation, yet despite all the advancements, there is still much we do not understand. The relationship between the Higgs and inflation remains a puzzle, filled with unanswered questions. Will we ever fully understand how these interactions shaped our universe? On this path to understanding, it is crucial to remember that science advances in small steps. Each experiment, each observation, each new theory brings us a little closer to unraveling the mystery of the Higgs boson and its role in cosmic inflation. In the meantime, we continue exploring, questioning, and marveling at the vastness of the cosmos and the secrets it still holds. What will the future hold in this quest for knowledge? The story of the Higgs boson and cosmic inflation is just one piece of a much larger puzzle. Human curiosity is insatiable, and each new answer generates more questions. Thus, the journey of discovery continues, challenging our perceptions and expanding our understanding of the universe. In this vast stage, the Higgs boson stands as a key player, inviting us to contemplate the mystery of our own existence and the cosmos that surrounds us. What happens when the predictions of physics do not align with reality? This is the dilemma we face when discussing the Higgs boson and its unknown coupling. At the heart of particle physics, the Standard Model provides us with an impressive framework for understanding the universe. But despite its success, there are aspects that do not quite fit. Why does the Higgs boson, despite being crucial, not behave exactly as we expected? Let's explore this troubling question. The Standard Model states that the Higgs boson interacts with other particles, giving them mass through a mechanism based on its own field. However, when scientists have measured these interactions, they have found discrepancies that cannot be ignored. What does this mean? Are we witnessing a limitation in our current theories? Or is there something deeper at play? Consider the case of the Higgs interaction with quarks, which are the fundamental components of protons and neutrons. According to the model's predictions, we should see certain ratios and relationships. But in practice, those values do not match. The difference may seem small, but in the world of particle physics, those slight variations can open the door to new discoveries. Could it be that there are particles or forces we have yet to identify? Another intriguing point is the relationship of the Higgs boson with leptons such as electrons. The theory suggests that the Higgs should couple in a way that allows leptons to acquire mass, but the measurements are not precise. This leads us to wonder, is there something we are overlooking? Perhaps some interactions are more complex than we believe, and the Higgs boson could be involved in a cosmic dance with other forces that we do not yet understand. What if there is more than one type of Higgs boson? Some theoretical models suggest the existence of multiple versions of this boson, each with its own set of interactions. This concept raises the question of whether we are observing only a part of a much larger puzzle. If other Higgs bosons existed, how could we detect them, and what implications would that have for our understanding of physics? The search for new particles is underway, but so far, experiments have been discouraging. Despite the sophistication of particle accelerators like the Large Hadron Collider, conclusive evidence of these mysterious interactions has yet to be found. Does this mean we have reached a limit in our technology? Or could there be hidden dimensions that we cannot perceive with our current tools? Now let's talk about energy. The way the Higgs boson couples to other particles is related to the energy of the vacuum. This concept is fascinating because it invites us to reflect on the very nature of reality. If the vacuum has properties that vary in different regions of the universe, how does this affect the way the Higgs interacts with particles? This could have profound implications for the structure of the cosmos. Meanwhile, physicists continue to work on their models and theories. The discrepancies observed in experiments have generated renewed interest in supersymmetry, an idea that posits the existence of partner particles for every particle in the Standard Model. If these particles exist, they could help explain the differences in Higgs interactions. But so far, the search remains fruitless. Why? Furthermore, we cannot ignore the connection between the Higgs boson and astrophysical phenomena. Current theories suggest that the Higgs could be related to dark matter or even dark energy, two of the great mysteries of the universe. If the Higgs plays a role in these interactions, could it change our perception of what constitutes matter and energy in the cosmos? As we advance in our understanding, we face a fundamental problem. How does the Higgs boson relate to gravity? This is a question that has intrigued physicists for decades. Gravity is the force that shapes the universe, but its relationship with the Higgs field and fundamental particles remains largely an enigma. Ultimately, the mystery of the Higgs boson's coupling is a reminder that science is a continuous process of discovery. Each new question opens the door to new possibilities. As we delve deeper into the nature of the universe, we are constantly challenged to reconsider our theories and seek answers beyond the known. The quest for truth is an endless journey, and the Higgs boson is just a part of that story. Particle physics may be complex, but its essence lies in our curiosity to understand the universe. Each discovery, each question brings us a little closer to unveiling the secrets of the cosmos. So as we continue to explore the mystery of the Higgs boson and its unknown coupling, let us remember that every question is an invitation to wonder and awe. What revelations await us in the future, only time will tell. What if I told you that the Higgs boson might not be the only one of its kind? Although the discovery of the Higgs boson was a significant breakthrough in physics, some scientists believe that there could be other versions of this intriguing component of the universe. But why think that there is more than one? What implications would this have for our understanding of the cosmos? To understand this idea, we must first remember that the Higgs boson is fundamental for conferring mass to particles. However, what many do not know is that there are theories suggesting that there could be multiple Higgs fields, each with its own boson. Can you imagine a universe where each type of particle had its own Higgs? This would greatly complicate our current understanding of physics, but it could also open the door to new realities. Now, let's talk about its properties. If there are other Higgs bosons, they could have very different characteristics from those we know. This means they could interact in ways we have yet to observe. What if one of these bosons were responsible for phenomena we have not yet explained, such as dark matter, for example? The idea that the Higgs boson could have siblings is both fascinating and terrifying. Moreover, some suggest that these additional bosons could exist in dimensions we cannot detect. What does this mean? Imagine a universe with more than the 4 dimensions we know. What would those dimensions be like? What kind of interactions would the bosons have in those spaces? The notion of hidden dimensions suggests that the universe could be much more complex than we think, and that the laws of physics we know might just be the tip of the iceberg. Another intriguing question is, if these bosons are invisible to us, how can we even begin to search for them? Scientists are developing new techniques and technologies to explore these possibilities. The search for particles we cannot see is a titanic challenge. However, each detection attempt could reveal something that would change our understanding of the universe. Imagine that at some point, we managed to detect one of these hidden bosons. What implications would that have for our understanding of matter and energy? The possibility that other versions of the Higgs boson exist could mean that there are still many unanswered questions. Each discovery would open new doors to even deeper mysteries. On the other hand, the existence of multiple Higgs bosons also poses a dilemma. How would this fit into the standard model of physics? The standard model has been our guide to understanding fundamental particles and their interactions. However, if it is confirmed that there is more than one Higgs boson, this could indicate that the model needs a significant revision. Are we on the brink of a new era in physics? So how does all this relate to the search for dark matter? Some researchers believe that the interactions of these additional bosons could be the key to understanding this mysterious form of matter that makes up a large part of the universe. Could the Higgs boson, in its unknown form, play a crucial role in the composition of dark matter? And not only that, the existence of other Higgs bosons could also influence our understanding of time and space. What if these alternative fields altered the way we perceive time? This concept may sound like something out of a science fiction movie, but theorists are seriously exploring these possibilities. It is evident that if these theories are correct, our universe would be a much more intricate and astonishing place. But as in any good mystery story, there are always more questions than answers. As we continue to investigate, we may discover not only new bosons but also new laws that govern how everything works. At its core, the search for these invisible bosons reflects our innate curiosity. Science advances through questions that challenge what we already know. What new truths and realities await us in the future? Are we ready to accept them? The answers could redefine our understanding of the universe and our place in it. So as we continue to explore these questions, let us remember that the Higgs boson, in all its forms and possibilities, is just a chapter in a much broader story. Research into its existence and properties continues, and with each advancement, we get a little closer to unraveling the mysteries that surround us. Who knows what discoveries await us around the corner? The adventure is just beginning. Have you ever felt that there is more to the universe than our senses can perceive? The Higgs boson, that particle that has revolutionized our understanding of physics, could also be the key to unlocking hidden dimensions. But what does this really mean? Could the Higgs boson be a connection to other worlds that we cannot see? The idea of hidden dimensions may sound like something out of a science fiction novel, but in the realm of theoretical physics, it is a very serious concept. Physicists have proposed that in addition to the 3 spatial dimensions and time that we know, there could be more dimensions that we simply do not perceive. How does the Higgs boson fit into this intriguing puzzle? Imagine that the Higgs boson acts as a kind of door between our universe and these hidden dimensions. This idea suggests that if the Higgs can interact with these additional dimensions, it could open up new possibilities about the nature of reality. But what implications would this have for us? Does it mean that there are more particles waiting to be discovered in a plane that we cannot yet see? Scientists have speculated that the Higgs boson could be a manifestation of these hidden dimensions. In other words, what we observe as the Higgs boson could be just a shadow of something much larger, something that exists in a space we are not equipped to experience directly. But how can we test something like this? How can we investigate something that is beyond our reach? One of the most fascinating theories suggests that these additional dimensions could be very small, even so tiny that we could not detect them with current instruments. However, their existence could have a profound impact on the forces that act in our universe. For example, if the Higgs boson has links to these dimensions, it could influence how other particles behave. But could this also mean that there are forces at play that we do not fully understand? Exploring these hidden dimensions is not just a theoretical exercise, it may help us unravel the mysteries of gravity, which has been an enigma since Newton formulated his laws. If the Higgs boson is related to additional dimensions, it could offer answers about how gravity interacts with other fundamental forces. But what would be the consequences of discovering that gravity is just a manifestation of something more complex? As scientists delve deeper into the research of the Higgs boson, questions arise about how these discoveries could challenge our notions of reality. If hidden dimensions do exist, what would this mean for our understanding of time and space? Could we one day access these dimensions and understand the secrets of the universe in a completely new way? Some researchers believe that studying the Higgs boson and its possible connections to hidden dimensions could revolutionize our understanding of physics. However, this path is fraught with challenges. Experimentation and observation are crucial, but how can one observe what lies beyond our visible universe? Science moves forward steadily, but the answers are not always easy to find. An intriguing question is whether the Higgs boson could act as a bridge for communication between different dimensions. Could it be that other forms of life exist in these hidden dimensions? If so, how could we come to know them? The idea that there is more life and more realities could completely change our perspective on our place in the cosmos. As new theories develop and experiments are conducted, the possibility that the Higgs boson is a link to hidden dimensions raises questions about the future of physics. Are we on the brink of a new paradigm that could transform our understanding of existence itself? The quest to unravel these mysteries continues, and each new discovery brings us closer to the truth. In summary, the Higgs boson is not only fundamental to understanding mass and the structure of the universe, but it could also be the key to unveiling deeper secrets about the nature of reality. The idea of hidden dimensions is a reminder that, despite what we already know, the universe still holds many mysteries waiting to be discovered. Are we ready for what we will find when we cross those doors? Have you ever wondered where the Higgs field comes from? This phenomenon that has revolutionized our understanding of modern physics has no clear origin, making it a true puzzle. If the Higgs boson is crucial for explaining how particles acquire mass, then why can't we answer the question of its own existence? Scientists have proposed that the Higgs field may have been present since the earliest moments of the universe, but what does this really mean? Imagine a vast ocean with small islands floating in it, each representing a fundamental particle. The ocean itself is the Higgs field, and the islands are the particles that emerge from it. However, what caused this ocean to exist in the first place? One of the most intriguing theories suggests that the Higgs field formed during the Big Bang. But how can a field arise from nothing? At the moment of the universe's creation, conditions were extreme, and it is believed that, in that chaos, the foundations for the Higgs field to emerge were established. However, this process remains a mystery that leaves physicists scratching their heads. Some researchers argue that the Higgs field is related to the symmetry of the universe. But what exactly is this symmetry? In simple terms, it refers to the idea that the laws of physics should be the same everywhere. If the Higgs field is a manifestation of this symmetry, then why does it seem to be so well hidden in the darkest corners of physics? Another fascinating aspect is that the existence of the Higgs field could be connected to the evolution of the universe itself. If it had not existed, particles would have no mass, and that would change everything, from the formation of atoms to the creation of stars and galaxies. But what if the Higgs field had never appeared at all? Imagine a universe devoid of matter as we know it, a place where gravity could not attract anything. It would be an empty, silent cosmos. Moreover, some speculate that the Higgs field could be just a part of a larger puzzle. If there are other hidden dimensions in the universe, could it be that the Higgs field comes from one of them? This idea suggests that the Higgs is not only fundamental in our known universe, but could also be a bridge to completely different realities. Is it possible that the Higgs is merely a manifestation of something much larger? The question of the origin of the Higgs field also leads us to consider its relationship with dark energy. Some scientists believe that the Higgs field and dark energy could be intimately connected, suggesting that the nature of the universe is even more complex than we think. But how are these two seemingly distinct phenomena related? The answer may lie in the pursuit of a unified theory that explains both the Higgs field and dark energy within a single theoretical framework. As researchers advance in their understanding of the Higgs, new questions arise. Could the Higgs field have had different characteristics in the past? There is a possibility that this field has changed over time, affecting not only the mass of particles but also how they interact with each other. Imagine a field that evolves, adapting and transforming like a living organism in constant change, and we cannot forget the crucial role that the Higgs plays in the stability of the universe. If the Higgs field is unstable or if its properties change, it could have catastrophic consequences. But how can we know if this might happen in the future? The answer may lie in researching the limits of the field and searching for signals that indicate its behavior. On the other hand, the Higgs field could also be the key to understanding the mysteries of gravity. If we discover how the Higgs originated, perhaps we can also unravel the secrets of how it interacts with gravity. But what if we never find those answers? The uncertainty can be daunting, but it is also what drives human curiosity. Ultimately, the origin of the Higgs field raises more questions than answers. Each discovery leads to new inquiries. And that is what makes research in particle physics so exciting. Are we really close to understanding this enigma, or are we simply scratching the surface of a vast ocean of mysteries? The search for the origin of the Higgs field also reminds us that science, at its core, is a journey into the unknown, where each step we take opens new doors and reveals unexplored landscapes. Each theory, each experiment brings us a little closer to unveiling the secrets of the universe. So, what does the future hold in our quest for the Higgs field? The road ahead is full of possibilities, and although we may not have all the answers now, the adventure of discovering them is what truly matters. In this vast universe, the Higgs field remains one of the greatest mysteries, and each question we pose brings us a little closer to the truth. What if I told you that despite having discovered the Higgs boson, there is still a puzzle that leaves us scratching our heads? Scientists have been working hard to understand the properties of this essential particle. But the data we obtain continues to raise more questions than answers. Why, after its discovery, do detectors fail to fully explain what they observe? This is the dilemma of the experimental puzzle. First, let's think about how the Higgs boson is detected. To find it, physicists use enormous particle accelerators like the Large Hadron Collider, when particles collide at speeds close to the speed of light. Conditions similar to those of the early universe are created. In that chaos, ephemeral particles, including the Higgs boson, are expected to emerge. But what happens when we find it? Why doesn't everything fit perfectly? When the Higgs boson was discovered in 2012, it was like finding the last piece of a giant puzzle. However, as scientists have been analyzing the data, they have realized that there are more pieces that should fit and don't. This discrepancy is both fascinating and frustrating. What does this experimental puzzle really mean? One of the most intriguing questions is that, although the mass of the Higgs boson has been measured, this figure does not perfectly align with what theories predict. Why is there this discrepancy? Some theorists suggest that there could be interactions that we have not yet detected, or even the existence of particles we have not imagined. This leads us to a world of possibilities that challenges our current understanding of physics. Sometimes scientists encounter data that makes no sense. Imagine being in a puzzle game and discovering that there are pieces that seem to not belong to the box. Experiments have shown that the Higgs boson may have more complex interactions with other particles than previously thought. So what do physicists do with this information? The answer is simple yet challenging. They keep investigating. Every time data is collected, there is hope that the next measurement will clarify things. However, they often find more questions than before. Why are the data so difficult to interpret? Some theories suggest that the Higgs boson could be involved in processes that are not well understood and that may be affecting our observations. Furthermore, physicists are trying to understand how these interactions affect other areas of physics. We have models that predict certain outcomes, but when experiments are conducted, sometimes these results vary. What happens then? The need arises to revise and adjust theoretical models. This process is like trying to fit the edges of a puzzle that don't quite match. In this sense, the search for the Higgs boson has become a journey of discovery that goes beyond simply confirming its existence. Each finding brings with it a new set of questions. Are we facing the possibility of more undiscovered particles or forces? Researchers are exploring this idea in search of answers. The dilemma of the experimental puzzle shows us that scientific knowledge is a constantly evolving process. It is not just about finding answers, but understanding that each answer can open new avenues of exploration. Thus, the Higgs boson becomes a key to unlocking deeper mysteries of the universe. Physicists are also wondering if there are limitations in the way we understand the very nature of the Higgs boson. Could it be that our measuring tools are insufficient to capture all the complexity of this particle? Physics is full of surprises, and the Higgs boson is a reminder that sometimes the answers we seek are beyond our current capacity for understanding. The ongoing search for answers takes us on a fascinating journey through time and space. Each new discovery can change our perspective on what we know. The Higgs boson, with its mysteries and puzzles, invites us to question and explore. Perhaps at its core, the true mystery is not just the Higgs boson itself, but what it teaches us about the process of discovery in science. Remember, every time we think we have solved a mystery, we may have only opened the door to another. So as we continue to unravel the secrets of the Higgs boson, we find ourselves at the crossroads of curiosity and wonder, reminding us that the universe still has much to reveal. The search for truth continues, and perhaps along that path we will find more than just answers. We may discover new mysteries that lead us to explore even further. The relationship between the Higgs boson and gravity is one of the great mysteries facing modern physics. Many wonder, how is it possible that a particle that seems so fundamental to understanding the mass of other particles does not provide us with clear answers about the force that keeps everything in place? Gravity? Gravity is one of the four fundamental forces of the universe, and yet it seems disconnected from the role played by the Higgs boson. Why is this happening? To understand this disconnection, it is essential to remember what the Higgs boson is. This particle is a manifestation of the Higgs field, which grants mass to particles through its interaction. But what about gravity? Gravity, according to Einstein's theory of general relativity, is not a force in the traditional sense. Rather, it is the curvature of space-time caused by mass. Thus, an intriguing question arises. If the Higgs boson provides mass, why is it not directly related to the curvature of space-time? Some theoretical physicists have speculated that the Higgs boson might have a more subtle role in gravity than we think. Imagine a universe where the Higgs not only intervenes in the creation of mass, but also influences how that mass affects the structure of space-time. Could it be that in some way the Higgs boson interacts with gravity in ways we have yet to discover? This idea opens a fascinating field of research. Another aspect to consider is the famous dilemma of quantum gravity. Gravity, as we understand it today, is based on general relativity, while the other fundamental forces, including electromagnetism, are described by quantum mechanics. So what happens when we try to combine these two theories? Researchers have been searching for a theory of quantum gravity that can unite them, but so far we have not succeeded. Could the Higgs boson have any relation to this quest? In this context, it is crucial to think about the very nature of space and time. Some theorists suggest that the Higgs boson could be a gateway to a new understanding of what constitutes space-time. If this is true, then the relationship between the Higgs and gravity could reveal to us not only how the universe works, but also what it is at its essence. But what does that really mean for our understanding of the cosmos? As we delve deeper into these questions, another concern arises. Why does the Higgs boson have such a peculiar mass? The mass of the Higgs is approximately 128 giga-electron volts. But why that particular number? Some scientists believe that this mass could be related to how the Higgs interacts with gravity, but the evidence is complicated and often elusive. Are we facing a case of the universe being finely tuned to allow for life? Or is there more at play? The search for answers to these questions leads us to a deeper exploration of the nature of the universe. Could there be additional dimensions influencing the relationship between the Higgs and gravity? Some theoretical models suggest that there are more dimensions than we can perceive, and that these hidden dimensions could contain answers to the mysteries we face. If the Higgs boson can be a manifestation of these dimensions, then its connection to gravity could be much more complex. As we explore these ideas, we must also consider the possibility that the Higgs and gravity are interconnected in unexpected ways. Could it be that the behavior of the Higgs boson influences how galaxies form and evolve under the influence of gravity? These types of questions are fundamental to our understanding of the cosmos and lead us to consider how each element of the universe is interrelated. However, despite all these advances, we still find ourselves at a crossroads. Many of the most advanced experiments in particle physics continue to provide no definitive answers about the relationship between the Higgs and gravity. Are we trapped in a cycle of unanswered questions? Or is there a path forward that we have yet to explore? The mystery persists, and as scientists continue to investigate, we may be on the brink of a discovery that could change our understanding of gravity and its relationship with the Higgs boson. What surprises does the future hold in this field? The exploration of these topics is not only fascinating, but also represents a journey into the unknown, where each answer leads to new questions. The connection between the Higgs boson and gravity is a puzzle that continues to challenge scientists. As we seek to understand how these two fundamental forces interact, we may be closer to solving some of the greatest enigmas of the universe. What revelations await us on the horizon of scientific research? So, as we continue to delve into these topics, let us remember that each answer we obtain is just the beginning of a new question. The pursuit of knowledge is an endless path, and the mystery of the relationship between the Higgs boson and gravity is just one chapter in this fascinating story. What will be the next great discovery that expands our understanding of the universe? What happens when we observe a significant difference between the mass of the Higgs boson and that of other fundamental particles? This is one of the most intriguing puzzles that physicists have faced in the quest for a deeper understanding of the universe. The question that arises is, why is there such a discrepancy? The mass of the Higgs boson is considerably higher than that of other particles, and this raises a dilemma known as the hierarchy problem. Imagine we are in a world where the sizes and masses of particles are quite similar to each other. In this context, the Higgs boson shines with a mass that is more than 120 times that of the proton. How is it possible that a particle playing such a fundamental role in the construction of the universe has such a disproportionate mass? This mystery leads us to question not only the nature of the Higgs, but also the very foundations of physics. One way to understand this phenomenon is to think about the delicate balance that keeps our universe functioning. The theory suggests that the mass of the Higgs boson should be related to the energy of the quantum vacuum. But experimental measurements indicate that this relationship is at a critical point, almost on the edge of stability. What does this mean? That if the mass of the Higgs were a little lower, the universe could be very different, perhaps even uninhabitable. Nature seems to play the role of an exceptionally precise engineer. Why does the Higgs boson have the mass it has? Some scientists speculate that the answer to this question could lead us to discover new physics beyond the standard model. What if the key to unraveling this mystery lies in the existence of supersymmetric particles? However, so far, we have not found evidence of these additional particles, making the situation even more puzzling. Most theoretical models predict that the mass of the Higgs should be in a much lower range. This leads to the thought that the universe could be tuned in an astonishingly fine way, as if it were specifically designed to allow the existence of life as we know it. But was there really some kind of cosmic calibration, or are we simply viewing things from the wrong perspective? We cannot ignore the fact that this enigma raises profound questions about the nature of reality. If the Higgs boson has such a high mass, what does this mean for the energy of the vacuum and the stability of the universe? Physicists are compelled to consider alternative theories, such as the idea that there are additional dimensions at play. If the Higgs is connected to these hidden dimensions, perhaps its mass isn't so strange after all. In this maze of theories and speculations, one wonders, could there be a mechanism that explains the difference in masses? Some proposals suggest that the interaction of the Higgs with other particles in the universe could be more complex than we think. Perhaps there are hidden interactions that we have yet to consider, interactions that lead us to a new understanding of physics. The hierarchy dilemma also suggests that the universe could be full of surprises. What other unknown particles or phenomena could influence the mass of the Higgs boson? As scientists continue to explore the microcosm, each new discovery could offer clues that bring us closer to solving this enigma. Experiments at particle colliders, such as the Large Hadron Collider, are precisely designed to seek answers. Could it be that in one of these experiments, we finally find the clues that help us understand why the Higgs has the mass it does? The search is intense, and with each passing day, the anticipation grows within the scientific community. Let us imagine a future in which the hierarchy problem is resolved. How would our understanding of the universe change? Would we move closer to a unified theory that explains both gravity and quantum physics? The excitement of discovering the unknown is what drives scientists to keep investigating. And every small advance can bring us closer to unraveling the secrets of the cosmos. Ultimately, the hierarchy problem is not just a technical dilemma. It is a reminder that, although we have made great strides in our understanding of physics, there are still many mysteries to solve. Nature is complex and often challenges our intuition. As we continue to seek answers, each question that arises seems to open the door to more inquiries. So, as we continue our journey through the universe and its mysteries, let us remember that each discovery is another piece of a much larger puzzle. The Higgs boson, with its perplexing mass, is just one chapter in a story that is still being written. And in this quest to understand reality, every step counts, every question pushes us forward, and the desire to know becomes the true driving force of our exploration. The fate of the universe is a mystery as ancient as humanity itself. Since time immemorial, we have looked to the sky and wondered, what will happen when all of this ends? At the heart of this quest lies a small but powerful participant, the Higgs boson. But how can a subatomic particle influence the future of the cosmos? To understand this enigma, we must first consider how the Higgs boson relates to the expansion of the universe. When the Higgs boson was discovered, it was celebrated as a monumental victory for modern physics. However, its existence raises even deeper questions. Could its behavior determine whether our universe will expand forever, or conversely, collapse in the distant future? As the universe expands, the Higgs field plays a crucial role in how particles acquire mass. But what would happen if this field became unstable? Some scientists suggest that, in the distant future, a vacuum collapse could occur, a catastrophic event that would completely change the structure of the universe as we know it. Imagine everything around us crumbling in an instant, and the laws of physics as we understand them fading away. Is this a real possibility? The concept of a vacuum collapse may seem like something out of a science fiction novel, but some claim it is a reality we must consider. The mass of the Higgs boson, so finely tuned, appears to play a fundamental role in this scenario. But why is it so important? The answer lies in the delicate balance between the stability and instability of the universe. Some theoretical models suggest that the Higgs field could be a place of unstable equilibrium. This means that, although we are currently in a state of stability, small changes could lead us to a new state in which the universe is no longer habitable. What would this imply for us and for everything we know? The idea that we could be living in a state that could change suddenly is unsettling, isn't it? But the mystery doesn't end here. What about dark energy and dark matter, which make up most of the universe? Some scientists have begun to investigate whether the Higgs boson has any connection to these invisible forces that seem to affect the expansion of the universe. The interaction of the Higgs with these entities could be the key to unraveling the ultimate fate of the cosmos. As we delve deeper into this mystery, unsettling questions arise. Could the behavior of the Higgs boson influence the fate of humanity? If the universe is expanding uncontrollably, are we destined to witness its eventual collapse? Or conversely, is there hope that the Higgs may offer us an escape, a way to understand and perhaps control our cosmic destiny? The dilemma of the Higgs boson and its relation to the fate of the universe leads us to question what we know about reality. Is it possible that the very fabric of space and time depends on this enigmatic particle? The search for answers confronts us with the possibility that the universe as we know it is just a chapter in a much larger and more mysterious book. As scientists continue to investigate the Higgs boson, the question persists: what future awaits us? We find ourselves at a crucial moment in the history of physics, where each discovery could change our understanding of the universe. Are we prepared to face the truth about our cosmic destiny? Experiments in particle accelerators are designed to unravel the secrets of the Higgs, but every answer we obtain seems to open new questions. Could the Higgs boson lead us to a new era of discoveries? The idea that we might be on the brink of understanding the fate of the universe is both exciting and terrifying. At the bottom of this sea of uncertainty lies a comforting truth: human curiosity and our tireless quest for knowledge. Although the Higgs boson may pose more mysteries than answers, each step we take toward understanding brings us a little closer to unraveling the secrets of the cosmos. Will we be able to decipher the puzzle of the universe before it is too late? So the next time you look up at the sky and wonder about the future of the universe, remember that at the heart of this mystery lies the Higgs boson, a particle that, despite its tiny size, could have a monumental impact on the fate of everything we know. Science advances, and with each discovery we get a little closer to answering the greatest question of all. What is the fate of the universe, and with it our own? The Higgs boson, one of the most fascinating particles ever discovered, has not only been a milestone in modern physics, but has also highlighted the limits of our knowledge. What does it really mean that it has validated the standard model of physics? And what about the questions that still remain unanswered? The validation of the standard model is a victory, but it also reveals gaps that make us doubt the completeness of our understanding of the universe. First, let's reflect on the fact that the standard model has been our best tool for understanding fundamental particles and their interactions. But why do some say that this model is incomplete? The answer lies in the interactions that we have not yet been able to observe. Although the Higgs boson fits into the model, there are phenomena that are not fully explained. For example, what about gravity? Why have we been unable to integrate gravitational force into the standard model? As we delve deeper, new questions arise. If the Higgs boson is fundamental to the mass of particles, why doesn't it fully explain the mass of everything we see in the universe? There are a large number of particles that seem to have no direct relationship with the Higgs, leaving a gap in our understanding. Is there something more that we have yet to discover? Could there be other particles that interact in ways we cannot yet measure? The fact that the Higgs boson has such a precise mass, almost as if it were tuned to allow for the existence of life, raises another intriguing question. Is it possible that this precision is not a coincidence but a clue about the deeper structure of our universe? What implications would this have for our understanding of physics? The idea that the universe is fine-tuned for life is full of mystery, and we cannot ignore what this might mean. And let's not forget about dark matter. How does the Higgs boson relate to this enigmatic substance that makes up most of the universe? There are theories suggesting that the Higgs could have hidden interactions with dark matter, which could help us unravel some of the deepest mysteries of the cosmos. But how can we test these ideas if we do not have the right tools? The dilemma of fine-tuning also leads us to question the future of the universe. If the behavior of the Higgs is so crucial to the evolution of the cosmos, what will happen if its properties change? This brings us to an even more perplexing question. Could the Higgs boson be responsible for the ultimate fate of the universe? Could its existence or behavior influence whether the universe expands forever or eventually collapses? As we continue to investigate, the hierarchy problem becomes increasingly relevant. The staggering difference between the mass of the Higgs and the masses of other fundamental particles is puzzling. Why does this discrepancy exist? Is there some hidden reason behind this difference that could lead us to new theories? The search for the truth about the Higgs boson also highlights an essential aspect of science: curiosity. Every answer we find generates new questions. So what does the future hold in our quest to understand the nature of the universe? Science is constantly evolving, and each discovery brings us one step closer to unraveling the mysteries that surround us. As scientists continue to explore, the Higgs boson becomes not only a symbol of success but also a reminder of our limitations. Could it be that this small yet powerful component of matter is the key to opening new doors in our understanding of the universe? Theories about hidden dimensions and other alternative realities continue to emerge, inviting us to imagine a cosmos much vaster than we have ever considered. As we look ahead, it is crucial to remember that every question that arises from research on the Higgs boson is an opportunity to expand our knowledge. There is a world of possibilities waiting to be discovered, and each mystery we solve leads us to new frontiers. Science, at its essence, is a journey into the unknown, and the Higgs boson is one of the most fascinating stops along that path. Finally, it is worth reflecting on the impact that the discovery of the Higgs boson has had on our perception of the universe. It has shown us that, although we have made great strides, there is still a long way to go. Are we ready for this adventure? The answer lies in our curiosity and desire to understand, in the constant quest that defines our species. The Higgs boson has provided us with a window into the mysteries of the cosmos. But it also reminds us that, in the pursuit of knowledge, every answer is just the beginning of a new question. The Higgs boson, a particle that has revolutionized our understanding of physics, is much more than just a simple building block in the construction of the universe. But what does its existence really mean? And why is it so crucial in our quest to understand the cosmos? Throughout our exploration, we have unearthed fascinating mysteries, but at the end of the day, questions arise that lead us to reflect on our place in the vast universe. Could the Higgs boson be the key to unlocking enigmas we have yet to imagine? The stability of the vacuum is one of those mysteries. What would happen if the Higgs field, which seems to keep everything in balance, became unstable? The idea that the universe could collapse in the distant future is undoubtedly unsettling. It pushes us to consider not only the ephemeral nature of existence, but also the role of the Higgs boson in our own survival. How far does the influence of this particle extend in the structure of the cosmos? As we delve deeper, we find the absence of supersymmetric particles that, according to theories, should have been revealed by the Higgs boson. This leads us to wonder, are we seeing everything there is to see in the universe? The lack of these particles suggests that there is more than meets the eye, a labyrinth of possibilities that we have yet to fully explore. What secrets does the universe hold in its vastness? Another intriguing question is the role of the Higgs boson in the creation of mass. While we have learned that this particle contributes to the mass of some particles, many questions remain unanswered. Why can't it resolve all the mysteries related to mass? This puzzle invites us to think about the very fabric of reality and how the fundamental forces intertwine. The energy dilemma is also a fascinating topic. Is the Higgs field constant throughout the universe, or does it vary from place to place? Imagining a cosmos where energy fluctuates leads us to rethink not only physics but also the essence of existence itself. Could this have implications for how we understand matter and energy? The multiplicity of the Higgs is another enigma that makes us question the nature of this particle. If there are several Higgs bosons, each with distinct properties, what does that mean for our understanding of physics? Could these hidden bosons be influencing the universe in ways we have yet to detect? Each new idea opens the door to more questions. The mystery of its own mass poses another dilemma. Why does the observed value of the Higgs boson not completely match theoretical predictions? This mismatch suggests that there is something larger at play, something that could change our understanding of the laws of physics as we know them. As we probe further, we are compelled to consider the possibility that the universe is more complex than we think. The link to dark matter is another piece of the puzzle. Some scientists believe that the Higgs could have hidden interactions with this mysterious substance that makes up most of the universe. Could the Higgs boson be the key to unlocking the secrets of dark matter? This connection suggests that by understanding the Higgs, we might also gain a better understanding of the structure of the cosmos. Then there is the fine-tuning of the universe. Why does the mass of the Higgs seem to be calibrated in such a way that allows for the existence of life? This phenomenon raises profound questions about the nature of the universe and our place in it. Is it a coincidence, or is there a deeper reason behind this precision? As we delve into the Higgs and cosmic inflation, we encounter the possibility that the boson played a crucial role in the expansion of the universe in its early moments. What implications would this have for our understanding of time and space? The idea that a single event could have shaped everything we know is undoubtedly fascinating. The unknown coupling of the Higgs with other particles also leads us to reflection. Why do its interactions not fully align with what the standard model predicts? This mismatch forces us to consider that there may be aspects of physics that we have yet to discover. Are we on the brink of a new paradigm that will forever change the way we understand the universe? Theories about invisible Higgs suggest that there could be versions of this particle that we cannot detect with current technology. What would this mean for our understanding of the universe? This notion of the invisible reminds us that there is much more to discover, that the knowledge we possess is just the tip of the iceberg. Furthermore, the idea that the Higgs could be a gateway to dimensions beyond the four we know is undoubtedly intriguing. What lies beyond our three-dimensional universe? The possibility of hidden dimensions challenges our perception of reality and invites us to dream of the unknown. Lastly, the origin of the Higgs field remains a mystery. Why does it exist, and how did it appear in the early universe? This question leads us to reflect on the birth of the cosmos and the events that gave rise to reality as we know it. The search for answers could lead us to uncover fundamental truths about the nature of the universe. Finally, the experimental puzzle continues to challenge scientists. Despite having discovered the Higgs boson, detectors still struggle to explain all the data they produce. What do we still need to understand? This dilemma reminds us that science is a continuous journey, full of surprises and discoveries. The relationship between the Higgs and gravity also leaves us with more questions than answers. How does the Higgs boson interact with this fundamental force? Exploring these connections opens new avenues of research that could change our understanding of physics. The hierarchy problem, with its vast difference between the mass of the Higgs and other fundamental particles, remains a dilemma in theoretical physics. Why this discrepancy? Reflecting on this question brings us closer to the limits of our knowledge and pushes us to keep investigating. Ultimately, the fate of the universe may be tied to the behavior of the Higgs. Will it expand forever, or will it collapse in the future? These questions are not just academic. They lead us to contemplate the future of everything we know. Through these mysteries, the Higgs boson becomes a thread that connects us to the great questions of life, the universe, and existence itself. As we close this chapter on the Higgs boson, it is clear that while we have unveiled many mysteries, the path to total understanding is fraught with challenges. The pursuit of knowledge is an endless journey, and each answer found only opens the door to new questions. The importance of the Higgs boson, therefore, lies not only in what we know, but in what we still have yet to discover. What other secrets does the universe hold in its vastness? The answer undoubtedly awaits us on the horizon of scientific exploration.